Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at an aspect in vectors. Of course, this is one of the basic or fundamental principles that the unit of vector is based on. And we're going to see how we can be able to describe vectors in maybe one or two different ways. But before that, I'll request us to kindly go to YouTube, search Sciences and Mathematics or Arts-Based Heritage 6110, so that you can be able to subscribe and engage us in the comment section so that we can be able to improve our skills in both maths and sciences. So in our channel, we deal with the aspect of biological and physical sciences, and we also deal with the concepts of mathematics. It will be easier for us to try and improve our skills, maybe if we try to engage one another and try to rectify one another, or maybe bring in new ideas one way or another. So in this case, for today's topic, we're going to see on how we can be able to represent vectors in a three-dimensional space. That is going to form our basis for our discussion. So without further ado, thank you and welcome. So as I've said, today's topic of discussion is going to be on how we can be able to represent vectors. And basically that is going to be on components of a vector. So that is so this in a way is going to assist us in trying to figure out how we can be able to interpret different representations of vectors, or whenever we come across a concept in vectors which has been represented in this particular format, it will be easier for us to understand. So in that case, as we said, our vectors are quantities with magnitude and direction, or quantities that represent magnitude and direction. And therefore, we are going to see that there are different ways in which they are going to be represented using magnitude and maybe direction. In this case, so there are some specific notations that we are going to encounter in vectors in a way that if maybe I'm talking of a vector u, then it's going to be represented using that way. And then there's maybe a vector v, and represent it using that way. There are other representations that we have learned in mathematics. If I talk of a vector a, and then I use an arrow, then that is going to represent also a vector. Now, in the aspect of components of vectors, we're going to see that there are also new ways or other additional ways in which we can be able to represent specific direction, especially when it comes to the rectangular coordinate system. So suppose I have a rectangular coordinate system that consists of this is the x, y, and z direction. So this one is a rectangular coordinate system that is representing vectors in three-dimensional space. So suppose I have a vector that is represented by a, and then I can be able to represent its magnitude or maybe the length using that letter r. Now, if I can be able to describe this vector a in terms of three-dimensional space, of course I'm just trying to illustrate that one, not to scale, but I'm just trying to illustrate that one so that we can be able to understand what it basically entails. So whenever we are trying to represent vectors, we're going to see that our vector in three-dimensional can be represented with its initial point of origin. That is, of course, at this particular point that we can be able to call O. So therefore, in this case, for this vector A, we can represent its component in the x direction by either using subscripts for numerical figures like A1, and then for the x direction, I can represent it using A2, and in the z direction, I can represent it using A3. So therefore, this is one of the ways in which we can be able to represent vectors. And in this case, for A1, A2, and A3 of these rectangular coordinates, they form up, or the concept of vector A, or they are the components of vector A, bearing in mind that this is with respect to the point of origin A. So we can also use some of the alphabetical or let us maybe say to represent vectors, or maybe the components. So in some of our videos in physics and chemistry that we have talked about, especially on the atomic structure, we talked about the concept of polar coordinates. So in this case, if we are trying to talk about x, y, and z direction, we can be able to represent the x component as I, and then the y component as j, and the z component as k. So therefore, whenever we are representing the x component of vector A, we can say that is x, and that is going to represent I, and that is going to represent the x-axis. J is going to represent the y-axis, and k is going to represent the z-axis, respectively. So therefore, the components for these vectors can be represented using A1. So in this case, this one has not told us in which direction the vector, that component of vector, is indicating. So therefore, we can write A1I to indicate that this is a vector component of vector A in the x direction. And then we have A2J, this is a component in the y direction. And then A3K, this is in the z direction, which is, so therefore we can be able to represent using a three-dimensional space or three-coordinate system or a rectangular coordinate system using this particular representation. So this basically refers to the, we can call this one the rectangular component, the components of vector A, which is this one. So therefore, that's one of the ways in which we can be able to represent the components of that particular vector. And therefore, someone can say that the above are simply the components of vector A in x, y, and z directions. Now, suppose we are maybe representing the vector A in form of an equation. Therefore, we can be able to say that vector A is represented as A1I plus A2J plus A3K. So the three aspects that we have talked about of I, J, and K are the components of these vectors. And as we have learned from the introduction to vectors, we said that a vector can have a magnitude. In that case, now that we have described the components of the three directions in three-dimensional space, we can be able also to describe the magnitude of that vector by giving it as A, the magnitude of A. And this mathematically is represented as the root of 1. It's the sum of the three components of the vectors. The square of the sum of the three components of the vectors is going to give us the magnitude. We're going to look at, or maybe in our video of the unity vectors, we're going to see on how these three components are going to be maybe solved in this case. That is why they do not appear in this section of the representation of the magnitude of vectors. So in particular, the position vector, the radii vector, in this case, which are indicated using that R, is a position vector, or the vector that is trying to indicate the radii vector from the point of origin A in the x, y, and z direction. So therefore, we can be able to represent the general direction, or maybe the general position of that vector using the x, y, and z direction by indicating that R equals xi plus yj plus zk. So that is the position vector of that particular direction, the x, y, and z direction. This one can as well be represented in form of a magnitude using this particular case of concept by trying to find out that R. I can just use a different representation. Now for this case, for r as well, it will be represented as the root of x squared plus y squared plus z squared. In that case, so that will be the magnitude of r. So we're going to see that these specific components of vectors are going to be applicable in both chemistry and physics, and especially when it comes to the concept of displacement, the acceleration, and maybe the atomic structure, especially in the concept of trying to describe the position of maybe a subatomic particle, which sometimes are regarded as waves. So in that case, we're going to also include maybe another component, whereby we are going to consider the angular displacement of that particular particle from the original or the point of reference. So in this case, I hope that this concept of components of vectors is understood, especially now that we have talked about some of them, and this is going to be a complementary video on some of them. Kindly check on our description box. It's going to have a list of some of the videos that we have discussed on the same topic. This is going to complement on it. So that is it for today, guys. Bye, God bless.